Thank you, Andy. I would like to welcome our keynote speaker for today, Rob Chandhok, President at Qualcomm Interactive Platforms and Senior Vice President at Qualcomm Technologies. Thank you.
Thank you. Good morning, everyone. So we're going to do the talk a little bit interactive at the end. I'm going to leave some time for question and answers. So think about that while you're watching. I know that this crowd is capable of asking questions. So we're going to go from there. So thanks for coming this morning and listening. I'm going to talk a little bit about the Internet of Things. And in particular, I'm going to talk about a view of the Internet of Things that is related to things that are around us physically, which is work that we're doing in the team there. By any measure, people talk about the Internet of Things as a very, in sort of a very large number. When you think about the addressable market for Internet of Things, numbers range from the ones you see up there, which I think are from Gartner and IDC, in the billions range. Other people that you talk to will say it's going to be in the trillions range. It also depends on what you sort of draw the boundaries around. I mean, there's some challenges, I think, with on the industry side of labeling almost everything new, especially if you're a VC. Probably everybody who walks in your door says they're doing something for the Internet of Things now, regardless of what it is. It was sort of like a little bit ago when people would say they're doing the mobile Internet or they're doing mobile. That label, to me, is both interesting and frustrating, because when it is applied so broadly, it really loses its meaning, right? The Internet of Things could just be, and I think it actually probably will turn out to be, what we're currently calling the next phase of the Internet, right? So when we're done building the technologies that will connect the next trillion devices, we won't call it the Internet of Things anymore. We'll go back to calling it the Internet. Similar to when the mobile web started and the mobile Internet started, we called it the mobile Internet, and we thought we were going to have to do all this different technology. And I don't call the way I get to the Internet on my phone, on my smartphone, I don't call that the mobile Internet. It's the Internet, right? So I think at some point, maybe 3 to 5 years from now, we'll just be back to calling it the Internet again. But until then, let's talk about the Internet of Things. One of the things that's interesting about the Internet of Things is things are being connected at the edge in a different way than we've been thinking about up until now. And so things at the edge are getting smarter, and things at the edge are getting more connected. So rather than just depending on connectivity between 1 or 2 devices like a Bluetooth connection, we're either talking about connecting things all the way back into the cloud or making clusters of connectivity that give you some user experience. So it ranges all over the consumer electronics side, and that's the kind I'm going to focus on, to real large big data problems that have a lot of sort of sensors out there, like managing cities or managing, GE always gives the example of managing all the sensor data that's coming back from one of their turbines, which is petabytes, right? So some of that problem is actually instrumenting things that weren't instrumented before, and then using sort of what we've been using to drive other analytics in the cloud to analyze the behavior of physical objects. So things that sort of that drive, I think, the experiences, and I'm going to sort of swing back to the consumer side of this, are thinking about topics like context awareness. So thinking about, how do I use the data that is around me to infer and drive the user experience I'm having in a different way? So if I walk into a room and the room knows it's me, or I walk into a place I've never been before and I can discover things about this auditorium, right? Maybe I could have walked in here and projected my slides from my smartphone without having them connected to a wire anywhere, because I could detect the projection system, and I would get that privilege because I was in the room and standing on the stage. Maybe we could get that fine grain, right, where we map from physical awareness and physical context into roles, responsibilities, privileges in the virtual world, right? And when it would be kind of interesting if I walked off the stage and I lost my ability to project because I'm no longer on the stage, right? Instead of it having to be passwords and pins and all kinds of authentication keys. Right? So that awareness of the physical world, I think, is a part of the Internet of Things that I think is going to change the way we experience technology. Connectivity, I think we're getting to the place, and you're starting to see a lot of motion there, and I'm going to spend a little bit of time talking about that today. Thinking about how things are going to be connected differently than they have in the past. You can see some initiatives for actually breaking down the vertical silos that have been around at the physical layers at the edge of the network So for example, Google and a bunch of companies have talked about building a standard called Thread on top of the 802.15.4 family of radio protocols, which is also where Zigbee and Z-Wave and other radios other radio families are used. And the basic reason for doing that is that those silos make it hard for the software guys to pull more things into the world, right? So we have to start thinking about, at the edge of the network, how do I make the ecosystem, the software ecosystem, the business ecosystem, more like the ecosystem that's on the web and the internet, which can move very, very quickly, rather than being stuck in standards committees and sort of vertical isolation, right? How can we make things move at that pace? And when I talk to people about this, and you'll notice I'll have a particular point of view of some of the things we should be doing, you know, the question isn't really should we do this. The question is, do you want to be part of it or not? Because it's going to happen, right? Saying that things are going to stay vertical and proprietary would be like AOL and CompuServe making that argument in the 90s, right, or in the 80s. Too old, I can't remember. Yeah, I just realized the other day that my kids have never had to dial up to the internet, right? So, and I don't have young children. My youngest is starting her PhD, so it's funny. And then interactivity. So a lot of the things, if you combine the communication and the context, you get new levels of interactivity in a way that you haven't had them before, right? I can now interact with things that are around me or things that are part of my persona, my digital persona can affect my physical environment in a way that I can't actually do. Sort of the edge of my world right now stops pretty much at my smartphone in terms of what I can manage digitally, right? But I want that to extend out into the world that is around me. And it has to be done better than it's being done now, and we're at the beginnings of that. So let's talk about that. So let's just look at the home, for example, right? One of the I think, really great observations that I heard about the Internet of Things actually came from Amir Feintuch, who at the time was at Qualcomm and now is at Int'l. He walked around the show floor at CES last year and he said, you know, we talk about the Internet of Things, but what I see here is a lot of Internet of Thing, right? And the Internet of Thing design pattern is, let's see, it's pretty easy for me to build a thing now. Hardware is getting easier and easier. And I can connect back to the cloud through a HTTP connection, and then from that cloud I can connect to my smartphone application. And that's really cool, but then I want another thing, and another thing, and another thing. So what I end up with is a situation where I have a lot of, basically a place where the answer to the question shouldn't be there's an app for that, okay? Because I don't think of every light bulb or every brand of light bulb as a different app. I don't think of every piece of equipment in my multimedia system as wanting to have a different application so I can control it, right? So, in an example, and actually you can go out there and buy all the things that do this today, and I can go get a refrigerator that will talk to this. I get an app for that. I get an app for the TV. I get an app for the laundry. I get an app for the thermostat, and maybe there's somebody in the cloud that's going to try to glue those things together. I would argue that the cloud isn't the right place always to glue those things together. I actually want to do that right where I am. But that's the situation that we have right now. So that fragmentation, I think, doesn't have a business or product basis to stand on. You can make all kinds of technology arguments about how that's an easier design pattern to do. But as a product person and as even a business person, I would say that's an ecosystem that has no legs. It can't sustain itself that way. So that transition is going to happen. The question is, how is it going to transition? It could transition into sort of a bimodal distribution of what we have some things happening right now where it's this kind of brand controls this part of the ecosystem and this other big brand controls this ecosystem. Or it could be open, like the web, which will drive I think, a huge ecosystem where people will be able to then differentiate on top of it and create meaningful businesses. But the fragmentation itself is part of the challenge. And what are the things that differentiate the problem of the Internet of Things at these edge from maybe where we are today? I mean, because you can say, like I said, it's easy for me to go get my device to talk back to the cloud, right? I mean, I have a fairly rudimentary sprinkler controller. It's not a big fancy company that does it, but I could pull out of my smartphone in my pocket and turn the sprinklers on at my house. I wouldn't do that because I don't know if my wife is outside in the front yard, so that would probably be a career-limiting move for me. But those kinds of things are really easy. But I can't tie my Nest thermostat and its knowledge about whether I'm home or not and things like that to that sprinkler system, right? So one of the things you have to do is fix how we discover things that are around. And it's not just devices, but it's actually also services. So when I walk into a room, how could I discover that video screen service or the audio service or the fact that there's a clock there? If I walk into or sit in a car, how do I discover that maybe I could set my favorite radio stations that way? So finding things is something that on the bigger internet we use DNS for. So we were used to looking up things by their website name. And DNS is an overlay over the internet that makes it very hierarchical. Well, that hierarchy doesn't work very well for things. Because I might have 1,000 things in my house. I don't want to have a DNS name for every one of them. What I want to do is find the switch for the living room, the TV in the den, right? Things with real names. And so there's systems that do things like that. I mean, one of the models I actually use is all the way back to the original Macintoshes and the way you used to find a printer in this thing called the chooser. And it would go off on the network, and every printer would say its name, and you would pick the one you wanted to print to. Well, we've been working on a system that does similar things to that, and there are other systems that do similar things to that. But we're trying to make it so it's an open, interoperable, off every operating system kind of system. The other thing you need to do is discover and identify services that are out there. You might want to say, for example, okay, all I know how to do is print. And maybe that TV advertises, well, I can speak that printing interface. So if I want to actually make my presentation, I print to that TV. And I don't have to know it's a TV and not a printer or anything like that. And systems will just work. So you want a system that actually grows dynamically so I can discover things I might not have seen before, and I can find things that I don't know about a priori. And that's, I think, an important part of the kind of next phase of growth of the internet, because we're going to be packaging services into physical devices. And I don't want to have to enumerate every single one of those configurations in order to get something meaningful. So take the example of printing again. In some systems, if I had a multifunction printer, I would call that a multifunction printer, and it would be known that multifunction printers had scanners and printers and faxing capabilities. Another way of looking at that, if you were an internet or a web programmer, you would say, I'm just going to build this box. I'm going to expose a RESTful API for printing, a RESTful API for scanning, and a RESTful API for faxing. And the fact that they're packaged in the same physical box or not doesn't really matter. Right? So I think we're going to have to see some interesting changes there. You know, adapt to dynamic behavior, I've hinted at this. The kind of activity at the edges of the internet isn't a fixed network, right? Yes, as I walk around, I maintain my internet connection on my smartphone. That's why I keep gesturing here, because that's where mine is. But that also doesn't take into account where I am other than latitude and longitude. If you think about it another way, all of these pieces about discovery and adaptation are around build a coordinate system where I'm 0, 0, and the rest of the world, locates itself relative to me, right? Rather than saying I'm at this latitude and longitude, which is me locating myself in the world. So it's a little bit of a flip from a design standpoint. Diverse transports. One of the challenges, as I hinted at when I talked about Thread before, is that we've, at the edge of the network, it's because of how hard it was to do. We've built systems that are very vertically isolated, that don't talk to each other, because some of those problems were really hard to solve 10, 15 years ago. Well, but again, to take from the lessons of the internet itself was built on top of multiple physical layers. And because of that, we've been able to innovate in two different sets of technologies. We've been able to innovate in software protocols, like how HTML has changed and how new protocols and things like Skype came over on top of it. At the same time, innovating as we go from 2G to 3G to 4G and new versions of Wi-Fi and all this. When we went from 3G to 4G, nobody had to rewrite their web applications. But at the edge of the network, if I want to go from Bluetooth to BTLE, or if I want to go from some system that uses Bluetooth to some system that uses Zigbee, I have to rewrite my app completely because they use a completely different set of protocols. And that's what initiatives like Thread and also Alljoin, which I'm going to talk about, are trying to work around. Security is really important. We've had a different kind of model at the edge of the network than the model that the internet is built on. The model the internet is built on is trust based on services. So when you talk to an Azure server or when you talk to a Gmail server, you authenticate to the service, right? When I connect to a Bluetooth device, I authenticate to the device. And then once I'm authenticated to the device, I get all kinds of privileges because it was designed by hardware people who thought, oh, well, that's what you mean to do is pair these devices. Well, that's why we're going to exchange paper business cards for a while until this is fixed. Because right now, if I said to you, let's exchange Bluetooth business cards, we would have to pair. And then after we did it, I could see all of your contacts. Because that's what the security model is built. It's like, oh, you must trust this device because you paired to it, right? So those kind of models have to change. They have to be able to be built up so you can use other roots of trust, other kinds of authentication that fit into the broader ecosystem at the edges of the network. I might want to use my Twitter password to log into my refrigerator, or to control my refrigerator, if that's how I choose to identify myself and establish ownership of that when I bring it into my house. And the other thing is interoperability. I think for the ecosystem to really thrive, it has to go not only over multiple radios and physical layers, but also over every operating system. So it can't be specific to an operating system. And a little bit of inertia in that right now as it's going out. So the parts that I'm thinking about, if you really want to put it into the context of how we talk about the internet and the web, is I often am talking about the Internet of Things near me, right? And I want to be very clear to point out that I'm not saying that the web is a bad thing and the cloud is a bad thing. Those are wonderful and wondrous things that are not, A, shouldn't go away, B, are extraordinarily good, and C, are part of this ecosystem. I'm just saying those design patterns that we use for the web don't necessarily apply when you're talking about things near me, right? So that's in some sense, if there's one thing I would like you to walk away with after this talk this morning is thinking about that. So I think we talked about all of this to enable, oops, sorry. Those of you who are taking pictures of slides, I'll give you 1 second. I think these slides can be put up somewhere. That should be fine, actually. Once they're public, Qualcomm lawyers say other people can get them. All right, so let me draw a little bit of an analogy because I do want to leave some time for Q&A. Let's just draw an analogy then to bring that home on the ecosystem side. Think about how we build our businesses right now on the web. If you're a startup and you're thinking about how you're going to run your services, even what you do this year is different than what you would have done 5 years ago. That's different than what you would have done 10 years ago. So when I was first on the internet, and I grew up on the internet at Carnegie Mellon University and then started my own company, and very early web servers, I think the first web server for my company was actually an old Mac 2 that we weren't using for something else, and it basically had like 4 web pages that I hand wrote in HTML. I would never build a system like that now because the first thing I would do is I would probably go set up an account on AWS or some cloud service that has all these building blocks built in, configure a few things, and in literally 5 minutes would have a more sophisticated website than I could have built in 4 months 5 years ago or 10 years ago, either whether they're doing on top of WordPress or Django or anything. There's just a slew of building blocks. And then on top of that, I would start connecting to other services that I could use in order to quickly accelerate what I want to do, which is build a differentiated service that isn't really about building a better web server or managing traffic or, for example, delivering ads. So if I want to get ads, I go get something. If I want to put a map up, I go get an API to that, and I pay the money to that person that does that. I can reach out into the ecosystem, right? And I can tie these things together in a way that lets me accelerate the new differentiated things. So when you see all the mashup applications that are out there, it's like Uber, but for cats. That kind of stuff is easy to build because there are APIs on the web side of this ecosystem that we can use to basically exchange services in a B2B way. So a lot of people, when they think about the web, think the web is mainly a consumer benefit because the browser was the interface. But it's a huge, huge ecosystem on the web API side, right? If you want to track the people that think about that really hard, follow Kin Lane, Kinlane, on Twitter. He runs around the world talking about web APIs and building those communities to build open interoperability to create commerce, right? So that's great. So that happens on the web. But we don't have that at the edge. So one of the things that we're starting to talk about is how do I make APIs interfaces between physical things so that we can actually start to build systems that use other pieces of the ecosystem without having to own all parts of the ecosystem. So if you get back to where we are right now, when I talk about, for example, the things in the home, right now I kind of make choices that really don't match how the home economy works, right? The home is actually a best-of-breed ecosystem. It's not a single-brand ecosystem. So when you buy a refrigerator, you go and you look it up and you buy the best refrigerator that you can buy the day that you're buying it. When you then, 2 years later, you're buying a washing machine, you go buy the best washing machine you can get for the money. Because you know these are long-term purchases, and you want to get the best that you can at the point you're doing that. You're not saying, if I don't get the same brand of washing machine, they might not be able to send messages back and forth between them, right? So that ecosystem, though, right now, the offers that are coming that have to do with automation or interactivity are built around vertical ecosystems. So I'm either going to get all my light bulbs from this one company, or all my appliances from this one company, or all my media stuff from this one company. Otherwise, it just doesn't work, right? And I think that's going to change. So we imagine scenarios where the APIs aren't so low level that you can actually still have room for differentiation, but still interoperate. So instead of saying to my house, for example, I don't necessarily need to know the location and to address every light bulb in my house while I'm standing here on stage. What I might want to be able to do is say, put my house in vacation mode, put my house in pretend I'm at home mode, and let the house figure out how to do that, right? So that's the kind of interfaces that I could build. If we build these higher level interfaces, developers can use them to create experiences. So we built some simple things in AllJoyn, for example, like a notification service that lets you ask something, if you're a thing that doesn't have a UI, ask something to display something for you. So there's a service that LG has built into their smart TVs that I can send a message from my phone, from an Arduino Uno, from anything, and actually get it to display on these commercial TVs. So I can throw a notification that says you have an incoming call from your phone that's across the room. I can have my game send a notification, hey, it's your turn to play the game. And I don't have to be next to my phone to see it. Those open ecosystems tend to drive developers to create really interesting experiences. So there's a lot I could talk about the specifics of AllJoyn and the alliance that's around it. In the lower right-hand corner, which is in very tiny print, says allseenalliance.org. That's a 90-company alliance, which includes companies like Qualcomm, Microsoft, LG, Haier, Electrolux, and LifeX, which is doing some really cool lighting stuff, and so on, that is working to build an open source implementation of a way to have some of the ideas come to life. And the whole reason for doing it is, in my opinion, the innovation opportunity is that there's a new set of experiences to drive here around the edges of the network and around the Internet of Things. And people who can understand that and see that, I think, are going to have opportunity. So with that, I'll take questions if anybody has a question. Good. I think it's being recorded, so they want you to speak into the mic.
Okay. How do you approach the data issue? It seems like a lot of the issues is people in the ecosystem want to control the data for their own business purposes, and the person who the Internet of Things belongs to wants to have some idea about where that data is going. And that seems to be a lot of the core around the issues around the siloed ecosystem you're talking about that we have now. And how do you approach that issue?
Yeah, that's a really good question. One of the characteristics of how we're thinking about the Internet of Things near me is that one of the things you want to do is preserve locality of reference, which is a thing you do in sort of hardware architectures and other computer science architectures. Things get faster, but they also get private and more secure. So in the examples that I've been talking about around the home, for example, these systems would work without any of the data going outside of the house. You might have intelligence, and by the way, my prediction is you will have pretty smart machine learning systems in your home, right, to do these things, and you can choose whether you get a benefit from sharing your data out. But I think you're correct in noting that that pull, that tug of war happening right now is based largely on this Internet of Thing design pattern, which says, I can't get the functionality I want unless I send the data to the cloud. And we really don't agree with that in the architectures that we've picked, because we see privacy and security as being really important. One of the things about security is if you want to make things more secure, I mean, there's always going to be attacks, there's always going to be bugs in your code. One of the things you do is you design the system to have less surface area. Well, the less connections I make outside my house, the better it is. I don't want a toaster from Shenzhen to be punching a hole through the firewall in my house and being a vector for an attack. So the data and the security and the privacy sort of all tied together to don't send anything further than you need to build a service that you want. And that's a different design pattern. And that's where innovation is going to happen in my mind. Have you guys not had enough coffee? Seriously? I'm not really comfortable with this concept of quiet Israelis. I mean, I have an office in Bet Shemesh, so I know.
Speaking of security, who is working on the security related to the All-Seen Alliance and All-Join?
Yeah.
I understood the concept that you just talked about, but I'm curious about more detail about it.
Yeah, so there's actually, in the Alliance, there's a security working group. So from the beginning, the connectivity framework of All-Join had basically a plug-in model for different security methods for either identity or encryption. And we implemented some, right, certificates, shared secrets, so forth. The architecture is actually being worked on now largely by Qualcomm, Microsoft, and Technicolor, actually. So Technicolor is pulling a bunch of the stuff that it learned from a system they were building called QIO, which they pulled into the Alliance and have been contributing code in that. So we're really lucky to have companies that, I mean, Microsoft really knows security, so we're really excited that they're contributing in that regard. I think we have time for one more question.
Where does the data privacy go? Everything within ICC, except when you analyze those licenses, they give the software company complete access to my device. Dropbox
Yeah.
has complete access to everything going on in my system. Now we're going to add a link to my device.
Yeah.
Where is privacy access?
So it's a similar question. So the question is, where is data privacy going? And you gave the example of Dropbox, the application getting access to a lot of stuff on the device. I think that's what I tried to at least hint at in the earlier answer, which is that in the world of these devices, what you want to do is basically not give them anything more than they need to do the job that they want. And sometimes that means that not allowing them to connect to the public internet, right? So actually the design pattern that All-Join drives, you don't even actually give the little devices IP addresses that can route to the public internet. So what we're trying to do is say, a place where you install a thing, if that's your place, then you can control the access at the edge of that place. And people will find ways around it, and people will build bad code. But instead of starting with the design principle that everything goes to the cloud, like there are other companies who will say, the first thing you do to connect something is connect it to the public internet, we think that's the wrong design principle. So connected doesn't mean connected to the public internet. And that's part of addressing what you're talking about. Okay? I'll be around a little bit later for questions, but thank you.